Hey guys, I'm sorry that I can't be here today, but I didn't want you to miss out on some extra review from the functions transformations that we talked about last class. Plus, I wanted to keep you on pace with the other Algebra 2 classes by getting your notes on function inverses. So today I'm going to have you watch this video to review what we did last time and then see the new stuff that you need to know for today. Let's talk a little bit about our schedule coming up. So obviously today you're watching this video. If you need to pause and rewind so that you can kind of check something out again, something you didn't understand, just kind of ask the sub and he or she can rewind it for you and rewatch a part to make sure that you understand. All right, so then today you're getting 2 homework assignments. Last class you got homework assignment number 3, which is the function transformations worksheet. Okay. Today you're getting homework assignment number 4 and number 5. So you're getting the inverse functions homework assignment, and you'll get the notes for that today. You're also going to get the Unit 2 test review because I want you to go ahead and have that to be able to start working on it because our schedule gets kind of weird the next few days. On Friday, I will also not be here. A lot of you will be on a USVA field trip, so you won't be here anyway. But for the rest of you, you're going to be working on the on homework assignment number 3, the functions transformations, on homework assignment number 4, the inverse functions, and on this test review. Use your time in class to get as much of this done. Use each other if you have questions. I'm not going to be here. I am going to leave some answer keys for you so that you can see what you should be getting. But if there's stuff you run into that you don't understand, be sure to ask your classmates and you might be able to figure it out before next week. Next week gets really weird. Remember, we do not have well, you do not have school on Monday, you lucky dogs. I will be in here post-surgery hanging out with your parents at Touch Base. So you'll come in on Tuesday. Next week, I'll see you Wednesday and I'll see you Friday. Wednesday, we do have normal class, but the seniors will be gone for that with their field trip. For the rest of us, we're going to be doing some review. I would really like to take the test on Friday next week. That would be the 16th, but I'm not sure that's going to happen. What I might do is start teaching new material on Friday, and then we'll take our test the following Tuesday. And that would give you a chance to kind of get some questions answered and get those homework assignments in. So right now, let's plan for that. Watch this video today. On Friday, you're working on some homework assignments. When I see you next Wednesday, we'll be reviewing functions, transformations, and inverse functions. It'll be a chance for you to ask questions of me. And then we'll start getting into our next unit, maybe the end of class Wednesday and Friday. And then the week after, which would be Tuesday the 21st, I believe, that's when we're going to take our unit test for Unit 2. So all the homework assignments will be due then. All right, if you have any questions, please email me and I'll get back to you. Otherwise, I'll see you next week. Well, let's go through this warm-up. These are the 3 types of problems that you had in the homework assignment on functions transformations. I wanted to do a few more of these so that you have a chance to see some and can get some of these in your notes. So let's take a look. Most of the problems that you had on that homework assignment were like problems 1, 2, and 3, where I gave you a function that looks like one of our function family functions. And I asked you to describe it and find a new table, find the new graph. I also asked you to find the domain and the range. So we'll practice that as well. So when you see a problem like number 1, the first thing I need you to realize is that this is an absolute value function. Okay, so there are a couple of things you should already know about this because it's an absolute value function. You should know what the table for absolute value function looks like because that's in our function families worksheet. Is it Friday? Come on. All right, let me fix this first. Oh, I think we got it. All right, back to it. So from your function families worksheet, you should know that your table for an absolute value function should have x values, -2, -1, 0, 1, 2. And the y value should be 2, 1, 0, 1, and 2. That's going to allow you to be able to make a graph of your regular absolute value function. So if I graph those points, insert a picture, drag it down here. Isn't this neat? Isn't technology wonderful, you guys? Somebody wake Mike up. Is he awake? Mike, are you awake? We graph these points, and we can see our absolute value function looks like a V. So there's our normal absolute value function. Okay. But that's not what we have here. Okay. So now looking at this equation, we have to figure out when I put this negative in front, which is really a -1, and when I put this -2 inside the absolute value, how does that change this graph? What you have to be able to figure out is whether this -1 and this -2 are A's, B's, H's, or K's. We talked about that last class. If you weren't here, make sure you get the notes from somebody. So is this -1 an A, a B, an H, or a K? Well, I'm multiplying it. That means it either has to be an A or a B. And it's going to be an A because this -1 is not part of what's happening to my X. If this -1 was in here with the X, that would make it a B. So in this problem, this -1 is an A value. So we need to know what A does to my graph. And A, we talked about last time, if it's negative, flips my graph vertically. Ooh. There we go. So an A value of -1 flips my graph vertically, meaning instead it's going to take whatever is above this x-axis and it's going to put it below the x-axis. Okay. Then we also need to figure out what this -2 does. Well, because I'm either adding or subtracting it, that means it's either an H or a K. And because it's part of my absolute value, it's part of what's happening to my X, that means it's an H value. So what does H do to my graph? Well, remember last time we talked about H shifts your graph left or right. So if I have a -2, that means it's going to shift my graph to the right. Remember that H is always the opposite of what you think it would be. I know we think minus, oh, to the left, but with H, it's always the opposite. So if you see X minus a number, that means you're shifting the graph to the right. If this was X plus 2, we would be shifting it 2 to the left. Okay, so we know that our new graph should be flipped vertically and shifted 2 to the right. Now, on the homework, I ask you to come up with a new table of values for this function. So we start with this, and we got to figure out how A and H not only change the graph, but how they change the table. Remember, whatever your A value is, you're going to multiply A by all of your Y values. If A flips my graph vertically, that means it's not going to change the X values, it's going to change the Y values of each of these points. So because my A is -1, I'm going to take each of these Y values and multiply it by -1. So again, because of this vertical flip, I'm going to take each of my Y values and multiply by A, which is -1. So 2 times -1 is -2. 1 times -1 is -1. 0 times -1 is 0. 1 times -1 is -1. 2 times -1 is -2. All right, H. Because H shifts my graph left and right, that means it's going to change the X values of these points. Okay, and as we shift it, that means we're either going to be adding it to our X values or subtracting it to our X values. If I'm shifting my graph 2 to the right, is that going to make each of these X values 2 bigger or 2 smaller? Well, if we're going to the right, it's going to make each of those X values 2 bigger. I'm going to add 2 to each of my X values. So I take -2 plus 2, I get 0. -1 plus 2 is +1. 0 plus 2 is +2. 1 plus 2 is 3. And 2 plus 2 is 4. So what I now have are 5 points that are exactly on the graph of this function. So I graph those: 0, -2, 1, -1, 2, 0, 3, -1, and 4, -2. And this is what my new graph looks like. And we can see that from our original absolute value to our new absolute value, that my graph has been flipped vertically and shifted 2 to the right. So on your homework, I should see the original table. I should see your new table. I should see both graphs. I also ask you for the domain and range. Let's talk about that. Remember, domain is how far left and right your graph goes. And we're talking about our new graph, not the original one. As this is going down, it's also going to the left forever. And as this is going down, it's going to the right forever. So my graph goes forever to the left and forever to the right. That would be x belongs to the real numbers. Or if you want to write that in interval notation, it would be from negative infinity to positive infinity. Remember that infinities always get parentheses. On your homework, you do not need to write the domain and the range in both set notation and interval notation. You can pick one or the other, whichever one you think is easiest. My range, squiggly bracket y line. My graph goes down forever. That would be negative infinity, which gets a less than. Y, which is less than. How far does my graph go up? This is the highest that it goes up. That would be positive 2. And because that's a normal point, this would be a less than or equal to. Now, remember, if we have one number and one infinity symbol, we don't write this. We just write the inequality sign, or inequality that has the number in it. So y is less than or equal to 0. I don't know why I wrote 2 there. Again, how high it goes up, I want the y value, not the x value. So this should be 0. Y is less than or equal to 0. Might be, you guys. Oh. If I'm writing that in interval notation, the farthest down it goes is negative infinity. The farthest up it goes is 0. And because that 0 is a regular point, because of this equal to line, I have a bracket. All right, increasing and decreasing means we're starting from the left and working to the right and figuring out whether our y values are increasing, meaning our graph is going up, or whether they're decreasing, meaning our graph is going down. So remember that this graph starts at negative infinity. This is going forever to the left. So as I start at negative infinity and I move from left to right, I see first that my graph is increasing. So my graph starts increasing at negative infinity. Where does it stop increasing at? What x value? It stops increasing right here. That x value is positive 2. Now, when you're talking about increasing and decreasing, you always have parentheses, no brackets. Because at 2, it is not increasing. It is switching from increasing to decreasing. So then that means my graph starts decreasing at positive 2. And it's going to keep decreasing forever to the right, which would be positive infinity. So basically, that's what you're doing on each of those first however many problems on your functions transformations homework assignment. All right? So let's move on to number 2. Paste up. All right, so when we look at number 2, the first thing you need to realize is that that is your reciprocal function. You know it's your reciprocal function because your x is located in the denominator of that fraction. So because it's the reciprocal function, again, you can look at your function family sheet and you should know what the table looks like and what the graph for that function looks like. For my reciprocal function, we had 7 points on that. And again, this is not something you need to memorize. You just need to know that you can get it on that sheet. So we had negative 2, negative 1/2, negative 1, negative 1, negative 1/2, negative 2, 0, and undefined, 1/2 and 2, 1 and 1, and last 2 and 1/2. So these are the points that are on your original reciprocal function. And we can graph those points to remind ourselves what the graph of the reciprocal function looks like. So we've got negative 2, negative 1/2. That's 2 to the left and then down halfway between 0 and negative 1. Negative 1, negative 1. Negative 1/2, which would be halfway in between 0 and negative 1, comma, negative 2. We don't have anything at 0. We have 1/2, comma 2, which would be halfway between 0 and 1, and then you go up 2. 1, comma 1, and 2, comma 1/2. So my reciprocal function looks like this. Man, I'm an amazing grapher. You guys don't even know. I'm like the Steve Jobs of graphing. I just thought of that because they play that movie, that preview for that movie, like every single day. Remember that with your reciprocal function, you have a horizontal asymptote on the x-axis, meaning that as this line and this line get closer, and they get closer and closer to that x-axis, but never actually touch. We also have a vertical asymptote on the y-axis. So as this line gets close down here and this line goes up here, they get closer and closer to that y-axis, but never actually touch. Now we need to see what this 4 and this 3 do to my graph. So we have to figure out, are the 4 and the 3 A's, B's, H's, or K's? Well, here I'm adding this 4. That means it's not an A or a B. It's either an H or a K. And this would be an H because it's part of what's happening to my X, right? It's in the denominator with my X. This 3 is a K value because it's being added or subtracting after whatever's happening to the X. So in this problem, we've got an H and a K. So we need to remind ourselves that H shifts my graph left and right. So if this is X plus 4, that means this graph is going to be shifted 4 to the left. Remember with H, it's always the opposite direction you think it is. So plus 4 means 4 to the left. With K, K shifts my graph up and down. And K is exactly what you think it would be. If you see plus 3, that means it's going to shift your graph 3 up. So my new graph is going to look like this, except that it's going to be moved 4 to the left and 3 up. So let's use that information to come up with my new table. So again, we have to think, what does shifting my graph 4 to the left do to these points? Well, if we're talking left and right, that means we're changing the X value. And if we're shifting 4 to the left, does that make these X values 4 bigger or 4 smaller? Well, going to the left would make them 4 smaller. So that means, because of this, I'm going to take each of my X values, and I'm going to subtract 4. So if I do negative 2 minus 4, I get negative 6. Negative 1 minus 4 is negative 5. Negative 1/2 minus 4 is negative 4.5. 0 minus 4 is negative 4. 1/2 minus 4 is negative 3.5. 1 minus 4 is negative 3. And 2 minus 4 is negative 2. All right, if I shift my graph 3 up, that changes my y values. If we're going up and down, that changes the y values of my function. Because it changes the y values, and I'm going up, does that mean each of these y values gets 3 bigger or 3 smaller? If I go up, that's 3 bigger. So I'm going to add 3 to each of these y values. Negative 1/2 plus 3, that's 2.5. Negative 1 plus 3 is 2. Negative 2 plus 3 is 1. Undefined plus 3 is still going to be undefined. It means you're not going to have a point on your graph that has an X value of negative 4. And we'll see why that is once we graph it. 2 plus 3 is 5. 1 plus 3 is 4. And 1/2 plus 3 is 3.5. So I can now graph these points to get my new graph. Negative 6 would be here. And 2.5 would be halfway up between 2 and 3. Negative 5, negative 5 comma 2 would be right there. Negative 4.5 comma 1 would be there. Negative 3.5 would be halfway between negative 3 and negative 4, and then 5 means I would go 5 up. Negative 3, 4 is 3 to the left, 4 up. And negative 2 and 3.5 would be 2 to the left and then halfway up between 3 and 4. So my graph's going to look like this and like this. Realize that as I shift these, so we can see that each of these parts of my graph got shifted to the left and then up. Not only did these get shifted, but my asymptotes got shifted as well. This vertical asymptote got shifted 4 to the left, so it is now right here. And this horizontal asymptote got shifted 3 up, so instead of being at 0, it's now at 3. So you can see where our graph goes. Okay? So again, in the homework, you're starting with the original table and the original graph. You're describing the transformation. You're making your new table, and then you're graphing those points to get your new graph. All right, let's talk domain and range. My domain, this is pointing forever to the left. This is pointing forever to the right, but it is not all real numbers, because does it include every x value in between? No. It goes from negative infinity to here, and it gets really close to -4, but never actually touches -4. Here, this graph starts really, really close to -4 as it goes to the right, but never actually touches -4. And you can see that in the table, right? Because we don't have a y value that goes with -4. So the way that we write that would be x does not equal -4. That means x is every single x value except for -4. If you were writing that in interval notation, it would be from -infinity to -4 with a parenthesis. Then we put a u, which stands for union, and we're combining that with another interval from -4 to positive infinity. My range, this is pointing down forever, this is pointing up forever, but it's not all real numbers, because does it include every y value in between? No. It does not include this y value right here where we have this asymptote, and that would be the y value of 3. So my range would be y is not equal to 3, because it includes every y value except 3. If we're writing that in interval notation, it would be from -infinity to 3 with a parenthesis, because we're not including it. Then we put a u, and then we go from 3 to positive infinity. So again, we're still going from -infinity to positive infinity, but we're not including that 3. All right, increasing, decreasing. So again, we're starting forever to the left, so we're starting at -infinity. And as I move from left to right, this graph is decreasing. And it's decreasing until I get here, okay? Because then my graph stops. So it starts decreasing at -infinity. It stops decreasing at 4, or excuse me, at -4. Remember then that we always use parentheses only when we're talking about increasing and decreasing. Okay. Then my graph comes up here. So it starts at -4, and as I move from left to right, it is decreasing again. So it's going to start decreasing at -4, and it's going to keep decreasing as I move to the right, and it goes forever to the right. That would be positive infinity. This graph is never increasing, which means we do the circle with the line through it to show that it's never increasing at all. All right, on to number 3. Again, if you have questions on these, you can email me. Make sure that you are signed up for Remind, because I'm also going to try to include this video there in case you want to watch it at home. I'm also going to put the links for the test review video there. All right, the last one of these, where you're doing all this work, you have to recognize on this one that we are starting with our square root function. So that means our original table has these 4 points. We've got 0, 0, 1, 1, 4, 2, and 9, 3. Again, I do not expect you to have these memorized. You get this information from your function family sheet. So we graph those points. We get 0, 0, 1, 1, 4, 2, and 6, 7, 8, 9, 1, 2, 3. Somebody wake Mike up. Mike, wake up. Quit falling asleep. All right. So now we have to figure out what this -1 in front of the x and this -1 here do to our graph. So we have to figure out whether they're A's, B's, H's, or K's. So obviously this -1 is being multiplied by the x. That means it's either an A or a B. It is a B because it is part of what is happening to this x. If it was an A, it would be a -1 out in front of the square root. So if my B value is -1, what does that do to my graph? Remember that B, if it's negative, flips your graph horizontally, meaning whatever is on the right side of your graph is going to flip over to the left side of your graph. So again, B flips my graph horizontally. Then this -1, obviously because I'm subtracting, that either means it's an H or a K. Because it is not part of what's happening to the x, because it is outside of that absolute value, that means it is a K value. K shifts my graph up and down. Because it's minus, remember that K always does what you think it would do. So that -1 means it shifts my graph 1 down. So how does that change these points in my table? Well, if my graph flips horizontally, left and right means it's going to be changing my x values. To figure out what B does, B, you always take your x values and multiply those by B. So I'm going to take each of these x values and multiply by -1. So 0 times -1 is 0. 1 times -1 is -1. 4 times -1 is -4. 9 times -1 is -9. Okay, with K, because K shifts my graph up and down, that changes my y values. If I'm going 1 down, is that making these y values 1 bigger or 1 smaller? Should be 1 smaller. So I'm going to take each of those y values and subtract 1. So 0 minus 1 is -1. 1 minus 1 is 0. 4 minus 1 is 1. Excuse me, 2. 2 minus 1 is 2. And 3 minus 1 is 2. So now I can graph these new points, 0, -1, -1, 0, -4, comma 1, and -6, 7, 8, 9, comma 2. So we can see our new graph and how from our original graph we flipped it horizontally. So this part came over here. And then we shifted it 1 down. So instead of starting here, it starts here. Okay. All right, domain range. Again, we're talking about the blue graph, the new graph, not the old one. So my domain would be squiggly bracket, x, line. This is pointing forever to the left. That would be -infinity is less than x, which is less than. It does not go forever to the right. It stops here at 0. Because that's a normal point, that's an equal to line. But remember, the way that I want you to write this in set notation is to not write the inequality that has the infinity. So what I really want to see here is just x is less than or equal to 0. If you're writing that in interval notation, it would be -infinity with a parenthesis to 0 with a bracket. My range, squiggly bracket, y, line. This graph does not go down forever. It goes right here, which is a y value of -1. That's a normal point, so it gets an equal to line, which is less than. How far up does it go? As this is going to the left, it is also going up forever. Up forever would be +infinity. But again, I don't want you to write the part that has the infinity symbol. I just want you to write this. If I put the y in front and the -1 at the end, remember my alligator should still be eating the y, so my range would be y is greater than or equal to -1. If I'm writing that in interval notation, it would be from, -1 is my smallest y value, so it would go first, and that -1 would get a bracket to +infinity. That's how up it goes, how far up. All right, increasing, decreasing. This graph goes forever to the left, so I'm starting way out here. As I move from left to right, my graph is decreasing, and it continues decreasing until we hit right here. And that x value is 0. So this starts decreasing at -infinity. It stops decreasing at 0. Remember, with increasing and decreasing, no brackets, always parentheses. This graph is never in Increasing. It is decreasing the entire time. So for increasing, circle with a line through it. So hopefully that helps with those problems. Again, those were most of the problems you had on that homework assignment. You also had a couple like 3, 4, and 5, where I give you a graph and I ask you to write the equation for this graph. To be able to do this problem, first thing you have to recognize is what type of function this is from the shape of the graph. This is a parabola. That means we are talking about our quadratic function. Remember that your quadratic function is f of x equals x squared. But this isn't our normal graph of f of x equals x squared. That looks like this. So we have to figure out how did we get this black graph to turn into this blue graph, okay? So what happened to it? I can see two things. I can see that we took this graph, we didn't flip it, we shifted it first to the right. And to figure out how many to the right, I look at this, we call this point the vertex, that very bottom of my parabola. Instead of being at the origin, is now moved over 1, 2, 3, 4 spaces. That means this graph was shifted 4 to the right. And then it also looks like it was shifted up. And again, looking at that vertex, I can see that it was shifted 1 up. So what does that mean I need to add into this function? Well, if I'm shifting 4 to the left, that's an h value. And if I'm shifting 1 up, that's a k value. So when I rewrite this, it's going to be f of x equals. Remember that with h and k, you're always adding it. H is always part of what's happening to this x. And in this problem, my x is being squared. So to show that it's part of my x, I can't just write x minus 4. Remember minus because with h, it's always the opposite of what you think. 4 to the right is going to be minus 4. I can't just write this. I need parentheses around it so that that h is part of what's happening to my x. Then the k goes after. And k, again, is always what you think it is. So if it's 1 up, that means it's going to be plus 1. And an easy way to check this on a quiz or a test is going to be to plug this function into your calculator to make sure that it matches this. Especially on a multiple choice question. You really wouldn't have to go through all of that work. You could plug them into your calculator to see which one ends up being the graph that you have here. All right. Let's move on to the next one. So 5 and 6. Again, we're taking these graphs. First, we need to figure out what the shape is. So in number 5, this is a square root function. We can tell by the shape. But remember that normally my square root function starts here at the origin and goes off like this. So what has happened to get from this graph to this graph? I actually can think of 3 things this time. First thing, it's been flipped. Now, has it been flipped vertically, meaning what went on top goes to the bottom, or has it been flipped horizontally, meaning what was on the right goes over to the left? It's actually had both. It's flipped vertically. And it's been flipped horizontally. So if I flip it vertically, realize that this was above the x-axis goes below. And then I flip it horizontally, meaning that this that was on the right now moves over to the left. So you can see that's almost what we have. There's also one other thing that's happened. That graph has shifted 1 to the left. You can see because instead of starting at the origin, it starts at -1, 0. Let's get rid of these for a second. So it's been flipped vertically, it's been flipped horizontally, and it was shifted 1 to the left. So normally, our square root function is f of x equals the square root of x. But obviously now, because we've done some stuff to it, it's going to change. So we need to remind ourselves, if it was flipped vertically, is that going to be an A, a B, an H, or a K? Flipped vertically is going to be an A, and it means that my A is a -1. So when I write this, in front of my square root, I'm going to put a -1, which really means I only need to put the negative sign. I don't really need to write the 1. All right, if it flipped horizontally, that's a b value, and it means that my b is -1, which means inside my square root, I'm going to have a negative in front of my x, a -1. You don't need to write the 1. You can just write the negative. And the last thing, the shifted 1 to the left, that's going to be an h value. Remember that h is always added or subtracted with my x. So that means it's going to go inside this square root. Because I'm going to the left, that means I'm going to add 1. Now, for something that's a little more difficult than you need to know right now, this negative just needs to go outside the parentheses. It's still inside the square root, but you need to have a +1 here, and that means you'll need parentheses around this. And again, you can double check by putting this into your calculator. You won't have to worry about that on a test, but just kind of a heads up. Last one of these, looking at this, obviously because of the shape of the v, we should know this is an absolute value function. So our original function should look like this: f of x equals the absolute value of x. But that graph is a right side up v. This graph has obviously been changed a couple ways. First, from my original absolute value, which is like this, it's been flipped vertically. So instead of opening up, it now opens down. So we've had a vertical flip. But that would just put the graph right here. So then to get it up here, we also have to shift the graph up. And again, we can look at this vertex. Instead of being at the origin, it is now at +3. So that tells us that it shifted 3 up. So because it shifted 3 up, that means this equation is going to change. A vertical flip means, just like it did over here, that we're going to have an a value of -1. So when I write my new function, that means I need a -1 in front of my absolute value. I can either write the -1 here or just put the negative sign. And if we're shifting 3 up, that's a k value. So that means I'm going to be adding 3 outside of whatever's happening to the x. So that +3 is not going to be in here with the x. That would shift it 3 to the left or the right. This +3 needs to be out here. So that is my equation for number 6. So those problems hopefully shouldn't take you anywhere near as long as the problems like number 1, 2, and 3 on the warm-up did. Last one. I gave you a problem where I gave you this graph. It's not part of my function family. It's just a graph kind of using a bunch of points and a bunch of lines. And then I ask you to graph these. So I tell you that this graph is the graph of f of x. We got this horizontal segment, and then we go down to here, and then another horizontal segment. Okay. So then I ask you to graph these. So first, if I start with this, that might be the easiest way to do it. What's different from this to this? Obviously, we have this -1. And that -1 is where? It's in front of my f of x, which means that that -1 is really an a value. So if my a value is -1, what does that do to this graph? Well, it flips it vertically. So that means to get the graph of this, I need to take this black graph and flip it vertically, meaning whatever goes on top of my x moves down below. Whatever's down below my x-axis moves above. You can just do that by taking this point and saying, okay, instead of being 3 above the x-axis, I'm now going to move this 3 below. Instead of this point being 3 above the x-axis, I'm going to move it 3 below. This point that is on the x-axis, because it's on the x-axis, when I flip it, it's going to stay on the x-axis. Then this point that is 1 below moves 1 above. And this point that is 1 below moves 1 above. That's what it means to flip these vertically. Then you just connect your dots again. So horizontal line, steep line, and then horizontal line. And you can see that from the black graph to the blue graph that I flipped the black graph vertically. So that's what you're doing on that. All right, let's finish 8 and 9, and then we'll get to our notes on inverses. Do-do-do-do. 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 Sorry. Mike, wake up. Seriously, Mike, this is ridiculous. Wake up and quit asking to go to the bathroom and quit texting Brittany. All right. So for number 8, again, I have to kind of think what's different from the function in number x, so f of negative x, to this, so from f of x to f of negative x. Well, obviously, we have this negative 1 in here with the x. I'm multiplying it by x, which means it's either an a or a b, and because it's part of what's happening with my x, it's a b value. So what is b being negative 1 due to my graph? It flips it horizontally. That means to get my new graph, I take whatever was on the right and I move it to the left. I take whatever's on the left and I move it to the right of my y-axis. So this point here, instead of being 4 to the left of the y-axis, I'm going to move it 4 to the right. So this point moves over here. This point here, instead of being 1 to the left of the y-axis, is going to be 1 to the right. This point here that is on the y-axis is going to stay on the y-axis. This point that is 2 to the right of the y-axis now moves 2 to the left. And this point that was 5 to the right of the y-axis now moves 5 to the left of the y-axis. And we draw our lines. So you can see that to get from this black graph to this blue graph, that I took the black graph and flipped it horizontally. So what was on the left moved over to the right. What was on the right moved over to the left. Last one, again, it might help to start with that original graph. Whoop, whoop. All right, so obviously this 2 and this 3 are not here in my original graph. This plus 2 means it's either an h or a k, and because it's part of what's happening to my x, that makes it an h. Because it says plus 2, that means it's going to shift my graph 2 to the left. Remember, with h, it's always the opposite. Plus means to the left. And then this plus 3 that comes after what's happening to the x means that's a k value. K always shifts my graph up or down. This is going to shift my graph 3 up. Well, that's easy, because all that means I need to do is take each of these points. I need to shift them 2 to the left and 3 up. So I'm going to take this point, go 2 to the left, and 1, 2, 3 up. Come on. Whoop. Making a mess. 2 to the left, and 1, 2, 3 up. Put it back right there. This point is going to go 2 to the left, and then 1, 2, 3 up. This point is going to go 2 to the left, and then 1, 2, 3 up. This point is going to go 2 to the left, and then 1, 2, 3 up. And this point is going to go 2 to the left, and then 1, 2, 3 up. And then we connect our lines in the same shape. And we can see, to get from this black graph to this blue graph, we took the black graph, shifted it 2 to the left, and 3 up. Okay? So hopefully that'll just give you some more examples to get you set with your functions, transformations, homework assignment. You will have some time in class to work with each other on Friday. So make sure you bring it with you on Friday. If you have questions on things, talk to your classmates. If the person beside you is not as smart as you are and you have a question, go find someone who is as smart or smarter than you to ask. Okay, just a rule. All right, so our new stuff. Today, we are going to talk about inverse functions. So put this in your notes. Inverse functions. We've seen the word inverse Okay, when we're talking about properties, the word inverse always came up when we were talking about canceling out. So additive inverse, adding a number and its opposite cancel each other out, or multiplicative inverse, where you're multiplying and two numbers cancel each other out. Okay, we use that same thing here. Inverse functions. Two functions are inverses of each other two functions are inverses of each other if they cancel each other out. Two functions are inverses of each other if they cancel each other out. Now, what that means is this. Remember back at the beginning of the unit, we talked about function composition, one function and another function. So if I have two functions, f of x and g of x, for those to be inverses of each other, it means if I do f of g of x, meaning if I take my g of x function and plug it into f, they will cancel each other out and just equal x. It also means the same thing switched. If I start with my g of x function and I take my f of x function and plug it in, they will cancel each other out and just equal x. Okay? So that's what it means for two functions to be inverses of each other. And if you plug one of them into the other, they will cancel each other out and just equal x. Now, there are three things that you need to be able to do when talking about inverse functions. The first is find the inverse of a function. The second, graph the inverse of a function. And last, prove that two functions are inverses of each other. Those are the three things you need to be able to do with inverse functions. You're going to see examples of each of these things on your homework assignment tonight. Okay. So first things first, how do I find the inverse of a function? It's actually pretty easy. To do that, I switch x and y in the equation. I switch x and y in the equation, then solve for y. So to find the inverse of a function, I just take the x and the y that are in the equation, I switch them, and then I get y by itself. So then solve for, I guess it would help if I put the y in there. So let's look at some examples. If I have f of x equals 2x minus 3, and I want to find the inverse of this function, the first thing that I have to do is I have to switch the x and the y. Now I see the x, but where's the y in this equation? Remember that f of x is really just a fancy way of saying y equals. So the y is where the f of x is. So now I'm going to switch x and y, which means instead of y equals, I'm going to put the x there. And instead of 2 times x, I'm going to do 2 times y minus 3. So I switched my x and y. Now I solve for y, which means I need to get this y by itself. To get y by itself, I have to get rid of the 2 and the 3. I get rid of the 3 first because it's farthest away. And instead of subtracting 3, I add 3 to both sides. So I get, over here, this is x plus 3. So I write x plus 3 equals 2y. Then to get rid of this 2, I divide by 2. Over here, I divide by 2. And I get y equals x plus 3 over 2. So that is my inverse of this function. Now, the way that we write that, the way that we write the inverse of a function is this. It's f, and then it looks like it has an exponent of -1. So when you see that, it just means the inverse of the function f. This is not f to the negative first power. This means the inverse of f. So in this problem, my inverse of f is x plus 3 over 2. Let's do a couple more. And in a lot of these directions, I don't say find the inverse. I say find this. You need to recognize that when you see this, it's talking about the inverse. So let's say I do g of x equals, let's do a trickier one. Let's do 4x plus 1 over 5 minus 2. So I want to find the inverse of this function. So first, I need to recognize that this g of x is really just a fancy way of saying y. Then I switch my x and y value. So instead of y equals, this becomes x equals. Instead of 4 times x, it's going to be 4 times y plus 1 over 5 minus 2. So I switch x and y. Now I resolve for y. So I get this y by itself. That means I got to get rid of the 4, the 5, the 1, the 2. So who's farthest away? This 2. So I'm going to add 2 to both sides. These 2's cancel out. I get x plus 2 equals 4y plus 1 over 5. Now the 5 is what's farthest away. To get rid of it, instead of dividing by 5, I'm going to multiply by 5 on both sides. Over here, the 5's cancel out, and I'm just left with 4y plus 1. Now over here, I'm not just multiplying this 5 by the x, or just multiplying this 5 by the 2. I'm multiplying 5 by all of this. So how do I show that I'm multiplying 5 by all of this? I need to put all of that, meaning the x plus 2, in parentheses. You can go ahead and distribute if you want, but you actually don't need to. It's just extra work, so I would not. Just leave it like that. Now I get rid of the 1. Instead of adding, I subtract. So on the left side, I now have 5 times the quantity x plus 2 minus 1 equals 4y. And then last, I divide by 4. And that means over here, I divide the whole thing by 4. These cancel out, so I get y by itself. In this problem, because I called my function g, I would write the inverse like this. G, the inverse of g of x equals 5 times x plus 2 minus 1 over 4. If you wanted to distribute, it would be this. 5 times x is 5x. 5 times 2 is 10, but then you'd be doing 10 minus 1, which is a positive 9 over 4. So I would accept either of these as my answer. One more of those. You'll see some of these on your homework. If I call this j of x, and I do, let's do x minus 3 squared plus 4. So again, my first step, if I want to find the inverse of this function, is to switch x and y. I remember that j of x is really just a fancy way of writing y. So when I switch it, this becomes x equals y minus 3 squared plus 4. Now to get y by itself, I have to get rid of the 3, the squared, and the 4. So which one of those is farthest away? It's the 4. Instead of adding, I subtract 4 on both sides. So on the left, I now have x minus 4 equals y minus 3 squared. Let's cancel out. So now I have to cancel out this squared. So that begs the question, how do I cancel out a squared? Remember that addition and subtraction always cancel each other out. Multiplication and division always cancel each other out. So what canceled out a squared? It's a square root. So to cancel out this squared, I take the square root of this side. When I do, the only thing that happens is the square and the square root cancel out and just leave me with y minus 3. But if I take the square root of one side, I need to take the square root of the other. So now on the left side, I have the square root of x minus 4. And then last, to get y by itself, I add 3 to both sides. So I now have y all by itself. But I want to write this in my inverse notation. So this would be j with a little -1 over top to show the inverse of j equals the square root of x minus 4. And then that plus 3 just goes after. So that's my inverse. That's the first thing I need to be able to do with these inverse functions. Next, graphing the inverse. It's also pretty easy. Hopefully you remember from Algebra 1, and Stephanie, I'm especially talking to you remembering from Algebra 1 because I know that your Algebra 1 teacher was, as you kids say, the shiznit. You should remember we saw the word inverse in Algebra 1, and we said to find the inverse, all you do is switch the x and the y values, just like we did over here. So if I have a graph and I want to find the inverse of that graph, all I do is switch the x and the y values. Now, when you do this, something very cool is going to happen. When you graph a function and its inverse, okay, let's start with the, not a. The graph of a function and its inverse oops, no parentheses needed there. I think I did that during first period as well. I get so excited about that apostrophe. And I did it again. What in the world is going on? Realize it is now 8 o'clock at night when I'm filming this. And I'm still at school filming this. So when you go home and you do your homework and you think, man, Mr. Kimball was making me work a lot outside of school, I want you to remember this. Mr. Kimball is also working a lot outside of school. So remember that. I love you guys, and I miss you. I'm at this, so you're watching this, it's Wednesday when you're watching this. I'm at this like district math meeting with a bunch of other math teachers. We're doing some important stuff, but know that I still would much rather be here with you guys. So when you graph a function and its inverse, they are symmetric over the line y equals x. So when we do an example, I'm going to show you what I'm talking about with that. So let's get a graph. Insert picture. Got this graph. I'm going to start off with a straight line. Let's on the homework, I already gave you these graphs. All right, let's, okay, that's good. All right, so I give you this graph, I want you to find the inverse of this graph. Well, to graph the inverse, all you do is switch the x and y values. That means you need to find some points that are on this graph. I see a couple. Looks like this is exactly on my graph here. That's the point 4, 1. And it looks like this point is exactly on my graph here. We'll call that -4, -1. So to find what the inverse of this graph is, all I do is I take these x and y values and I switch them. So instead of 4, 1, the inverse will have the point 1, 4. Well, where does it go? 1, 4. And instead of -4, -1, the inverse will have the point -1, -4. And I just draw my line through those points. So you need to find some points and graph that line. So for this black line, the graph of the inverse of this black line is this red line. Now, I told you that when you graph a function and its inverse, they are symmetric over the line y equals x. Remember that this is my identity function, right? F of x equals x. And the identity function is a straight line that goes through your origin. So it looks like, oh, that's terrible. Where's my answer? Take 2. It looks like that. That's better. So realize if you took this graph and you had it like as a sheet of paper cut out and you folded it along this blue dashed line, this part of the line would line up with this part of the line, and this part of the line would line up with this part of the line. So your graph and its inverse are always going to be symmetric over the line y equals x. That's what I mean by that. Let's do one more of these and then look at this last type. Let's do a so there's my graph. Okay. I want to find the inverse of this graph. So that means I need to find some points that are on this graph. Now, for this, I'm actually going to need 3. I need to know what this point here is. That's the point 2, 1. And then I need to know some point over here and some point over here. Doesn't really matter. Let's do this one. We've got 5, -2. And let's do this one. We've got 0, -1. So to find what the graph of the inverse of this looks like, I just need to take these x and y values and switch it. So if I do, the point 2, 1 becomes the point 1, 2. The point 5, -2 becomes -2, 5. And the point 0, -1 becomes -1, 0. And then we make our V shape. Right, this is our vertex, so it's still going to be our vertex. So that's what the inverse of this graph looks like. And if I were to draw my identity function, it's easy to see that if I folded this graph over this perfectly diagonal line, that this blue graph would lie right on top of this red graph. So that's how you graph the inverse. Last thing, goodness gracious, okay, is proving inverses. So in a problem like this, I'm going to give you the 2 functions, and you're going to have to prove it. Well, we prove it the way I wrote in our notes before. I take my 2 functions, I plug one of them into the other, and they should cancel out and just equal x. Okay? So for these examples, I'm going to come back here real fast to my functions that we found the inverse. So let's use that. 2x minus 3 and x plus 3 over 2. So let's say my f of x is, we said 2x minus 3. And my g of x is x plus 3 over 2. Okay? So to figure out if these are inverses, I'm going to take one of these functions and plug it into the other. So I could do this, or I could do this. I don't need to do both, just one or the other. Normally, I'm going to look at whichever one looks like it's easier, and I'm going to plug that into the other one. I think this one looks easier. So I'm going to take this and plug it into this function. So I'm going to do g of f of x, which means I'm going to take my g function, which is x plus 3 over 2. That's my g function. And what am I going to plug in for x in my g function? F of x, which means in place of this x, I'm going to put 2x minus 3. And then I'm going to simplify this. Well, I don't need these parentheses. 2x minus 3 can just be written like that because there's no distributive property. There's no number here that I need to multiply. Plus 3 over 2. So how can I simplify? Well, I have like terms here with this minus 3 and this plus 3. Negative 3 plus 3 is 0. And 2x plus 0 is just 2x divided by 2. And then what happens to these 2's? They cancel out, and I'm just left with x. So when I took this function and plugged it in here, everything canceled out and just equaled x. That's how I prove that those two functions are inverses of each other. Let's do one more of those. I want to look at this one here. So x minus 3 squared plus 4. So let's say my f of x equals x minus 3 squared plus 4. And let's say my g of x, we found the inverse was the square root of x minus 4 plus 3. Again, I'm getting that from that example we did earlier. So I want to prove that these two functions are inverses of each other. So that means I need to take one of them and plug it into the other. Okay? So I'm going to take, let's do this one this time. I'm going to plug this into this. So I'm going to do f of g of x. And on this one, I'll actually show you both. It really doesn't matter. So that means I take my f function, which is x minus 3 squared plus 4. But then what am I going to plug in for this x? My entire g of x equation. So that would be the square root of x minus 4 plus 3. So that this entire equation goes in for this x. So then here I have like terms. Plus 3 and minus 3 means I get the square root of x minus 4. This adds up to be 0, which means these cancel each other out. So I have the square root of x minus 4 squared plus 4. Then what happens with a squared and a square root? They cancel each other out and just leave me with x minus 4 plus 4. And then last, this negative 4 and this plus 4 cancel each other out and just leave me with x. Okay? I would get the same thing if instead I did g of f of x. Again, on your homework, you do not need to do both ways, just one or the other. If I'm doing this, it means I'm taking my g function, the square root of x minus 4 plus 3, and in place of this x, I'm plugging in my entire f of x function, which would be x minus 3 squared plus 4. So here to simplify, this positive 4 and this negative 4 cancel each other out. That leaves me with the square root of x minus 3 squared plus 3. Then this squared and this square root cancel each other out. And that leaves me with x minus 3 plus 3. And then my minus 3 and my plus 3 cancel out, and I just end up with x. That's how I know that they're inverses of each other. All right, so I know that's a lot of information, and it looks like this is going to take 1 hour and 9 minutes, which means it's taken most of this fourth period. Sorry about that. So again, a recap. I'm going to link this video probably tonight to remind, so that if you need to look at it again to help you out with some things, you can. You got 2 homework assignments today. Homework assignment number 4, the inverse functions, and homework assignment number 5, the Unit 2 test review. Make sure you bring those with you to class on Friday. On Friday, those of you that are here, those of you that are not on that USVA field trip, we'll have that entire class period to work on finishing these homework assignments. I will make sure the sub has a key to the functions transformations assignment and the inverse functions assignments so that you can pass those keys around to double check your answers. Now, I fully realize that this means you're going to be able to just write down the answers. Remember that when I grade the homework, I'm grading it on the work. There are a lot of these problems where you have to show me the work. So I'm going to need to see that, not just the answers. Realize you're going to take a test on this. I want to make sure you understand it. So it's more important to me that you try the problem ahead of time and then look at the key to make sure you're doing it right, rather than just writing it down on the homework assignment, turning it in. That might help you on the homework, but it's going to screw you over on the test. So just keep that in mind, okay? Friday, you're going to have a chance to work on those homework assignments. Next week on Wednesday, I will not see most of you seniors. You're going to be off doing your senior trip. For everyone else, we'll use that as a day to kind of go over homework assignment 3 and 4. Then Friday of next week, we're going to start the notes for Unit 3. But I definitely wanted to give the seniors a chance to see me before we take the test. And then we will take our test for this unit Tuesday the following week. So that's October 21st. If you have any questions, you can email me. My email, Kimball, B as in boss, D as in daddy, at pwcs.edu. I will have my phone with me this weekend. I can respond to emails if you have questions. But again, use your class time to kind of work on this stuff and ask each other about help that you need. All right. Have a great day. Have a great weekend. I'll see you next week. Deuce.